In order to multiply two matrices together, we need to know how to do a product that's called a dot product. And a dot product is basically the result of what you get when you multiply a row matrix by a column matrix. And so below I'm going to show you how to multiply a row matrix by a column matrix. And it's pretty simple to do. Now, the first thing we have to do here is, let's say I want to multiply this row matrix 2, negative 3, negative 1 by the column matrix 3, 5, negative 2. Okay, so all I do is I take the first element in the row and multiply it by the first element in the column. So in other words, I do 2 times 3. Then I take the second element in the row and I multiply it by the second element in the column. So that would be negative 3 times 5. And then I take the third element in the row and I multiply it by the third element in the column. So that would be negative 1 times negative 2. And then I add the three products together. So that would be 6 minus 15 would give me negative 9. And then negative 9 plus 2 would give me negative 7. So I get a value of negative 7. Now notice that the first matrix, size of the first matrix was a 1 by 3, 1 row by 3 columns. And notice that the size of the second matrix was 3 rows by 1 column. Notice that these two inside numbers are the same. If those inside numbers are not the same, then I would not be allowed to multiply these two matrices together, because I wouldn't have enough columns here to match the number of rows that I have here. So in that case I would say it's undefined. Let's do one more. So here, if I multiply this row matrix by this column matrix, notice that the row matrix is a 1 by 4 and the column matrix is a 4 by 1. So the inside numbers do match, so I know I'm allowed to multiply. Then I would just take the first entry here by the first entry here, and that would give me 1 times negative 5. And then I would take the second entry here by the second entry here, and that would give me negative 2 times 6. And then I would take the third entry by the third entry here, and that would be 3 times 7. And then I would take the fourth entry and multiply it by the fourth entry here, and that would be negative 4 times 8. So I end up with negative 5 minus 12 plus 21 minus 32. And if you combine these together, you should get negative 28. So when you multiply a row matrix by a column matrix, you're only going to get a single value in the resulting matrix. Now, when you multiply two matrices together that are larger sizes, you're simply going to, you can freeze that and read that paragraph if you want to, but I'll go ahead and just show you how we're going to do this. So if you wanted to multiply this matrix, which is a 2 by 3 matrix, and multiply it by this matrix, which is a 3 by 3 matrix, well, notice that the inside numbers, when we put them in the order that we're going to multiply them, notice the inside numbers are the same. The 3 and the 3 are the same. So that tells me that I'm going to be allowed to multiply these two matrices together. Now, something that's not of much consequence, but I'll go ahead and tell you, the result of the matrix, the resulting matrix size will be the same as the outside numbers. So I know that when I multiply these, the resulting matrix, its size will be a 2 by 3. But anyway, the more important part is to make sure you know whether or not you're allowed to multiply them, so we look at those inside numbers. Alright, now, so here's how we multiply this matrix times this matrix. So what I'm going to do is, I'm going to take the first row right here from the first matrix. I'm going to multiply it by each row of the column matrix. So I'm going to multiply this row by this column. So I've shown you that here. And by the way, this diagram is really more for instructional purposes. You don't really have to write it out like this every time, but this is instructional purposes for you. So think of it as an instruction manual. Alright, so if I multiply this row by this column, that would give me this product. Now we know this product is going to be a single number. Okay, well then I would take this same row and I would multiply it by the next column. So I multiply that row by this column. Then I would take that row and multiply it by this column. Go away. Alright, that row by this column, which I did right here. Okay, now what I'm going to do is I'm going to take this row, and I'm going to take this row, and I'm going to multiply this row by each one of these columns. So I'll take this row and multiply it by the first column, and I'll put that down here. Then I'll take this row times the second column, and I'll put that here. Then I'll take this row by the third column, and I'll put that here. Now, all these are 6 different products of a row by a column. And since I just showed you how to multiply a row by a column, you should be able to do this. So just think in terms of the products. If I have 1 and 2, their product is going to be 2. Negative 2 times negative 1, that product is 2. And then negative 1 times 1, that product is negative 1. So the first product is going to be 2 plus 2 minus 1, which gives me the 3 that I get right here. And then the next product, take this row with this column, I get 1 times 0, that's going to give me 0. Negative 2 times 3 is going to give me minus 6. Negative 1 times minus 3 is going to give me 3. And then 0 minus 6 plus 3 is simply negative 3. And then this row with the third column gives me 1 times negative 5, which is negative 5. Negative 2 times negative 2 is 4. And then negative 1 times 4 is negative 4. So negative 5 plus 4 minus 4 is just negative 5. And then now take the second row and multiply it by each column. So 0 times 2 would be 0. 3 times negative 1 would be negative 3. 2 times 1 would be 2. And then here, do this row times this column. 0 times 0 is 0. 3 times 3 is 9. 2 times negative 3 is negative 6. So 0 plus 9 minus 6 gives me 3. And I don't think I told you that over here, but anyway, 0 minus 3 plus 2 gave me negative 1. Alright, and then the last row with this column, 0 times negative 5 is 0. 3 times negative 2 is negative 6. And 2 times 4 is 8. So 0 minus 6 plus 8 is 2. And notice that, so this is the result of multiplying these two matrices together. So 3, negative 5 is the first row, negative 1, 3, 2 is the second row. And notice that the result is indeed the outside numbers 2 by 3. So the size of this result is a 2 by 3 matrix. Now, you can't multiply these two matrices in the other direction, because if you take a look at this, the inside number here are 3 and 2. So that tells me that if I tried to multiply this row right here by this column, I would not be able to, because I wouldn't have the same number of elements here as I have in this column. So therefore, if I'm trying to multiply in this direction, all I can say is that the result is undefined. Well, obviously, if A times B can be multiplied, but B times A can't be multiplied, then we can say that multiplication of matrices is not commutative. So in other words, I know that A times B with matrices will not equal B times A in general. Okay. Now, even if you can multiply in both directions, like for instance here, these are both 2 by 2 matrices, so I can multiply them in both directions, A times B and B times A. But notice that when I do A times B, if I take this row and multiply it by this column, I'll get minus 5 plus 6, which is 1 for the first entry. And then when I take this row and multiply it by the second column, I'll get 10 minus 4, which is 6 for this entry. And then if I take the second row and multiply it by the first column, I'll get 2 minus 3, which is -1 for this entry. And then if I take this row times this column, I'll get -4 plus 2, which gives me -2 for this entry. So A times B equals 1, 6, -1, -2. But then if I turn it around, let's say I multiply B times A. If I take this row by this column, I'll get -5 minus 4, which is -9. And then if I take this row by the second column, I'll get -2 minus 2, which is -4. And then I'll let you do the second row, but if you multiply the second row by the first column, you'll get 19. And when you multiply the second row by the second column, you'll get 8. And you'll notice that these two matrices are not equal, so therefore, obviously, A times B does not equal B times A. All right. Now, the last one here I'll do on this video, well, I'm not really going to do it. I'll just show you that here I have a practice problem with the answer given. And so you can see that this is a 3 by 2 matrix. And then this matrix is the second matrix is a 2 by 4 matrix. And so you can see that obviously I'm allowed to multiply them because the inside numbers match. And then you can see the outside numbers are 3 and 4. So the resulting matrix should be a 3 by 4 matrix. And you can see that the result I have certainly does have 3 rows and 4 columns. Okay. All right, so in the next video I'll wrap this up with some applications of matrix operations.